So today we're going to be working on the distance between 2 points on a number line. And to do that, we're going to apply our understanding of subtracting rational numbers and absolute value so that we can find the distance between 2 points on a number line using a formula. You know you've got it when you complete the examples in this lesson accurately using that distance formula. Before we jump into this lesson, we are going to talk about distance, and distance is always a positive value. So when you think about number lines and direction, those are positive and negative symbols. So if you're on a number line and you go to the left of 0, you are in the negative zone. And we indicate that you are to the left of 0 with that negative symbol. It means left. And then if we have positive numbers, they will not have a symbol on them, but it would indicate that it's positive then. And positive numbers are to the right of 0 on a number line. Now we could be looking at a vertical number line like a thermometer, and you could envision that if you are to above 0, you're in the positive digits. And then if you go below 0, then the temperature would read negative. So it's a directional symbol for the numbers. I can think of that on a number line again. You can visualize it. But we're talking today about absolute value, and we're talking about distance. And absolute value connects with that because it helps us to keep our distances coming out positive. So distance is always positive. And the distance a number is from 0 on a number line is called the absolute value. And absolute value symbols are these two straight bars. And we would read this problem as the absolute value. If you saw these bars, you would say, hey, that's the absolute value of x. And again, those absolute value symbols help us to keep our distance positive. It's how far is a number from 0 on a number line. And that's how you want to think about this. If you see these symbols, you're thinking about how far some values are from 0 on a number line. So let's just do two quick review problems. So we have the first one says, hey, what is the absolute value of negative 2.8? This is another way to ask the same question. We could just put the symbols in. And if you saw these symbols, you would know, so we were wanting you to find the distance number is from 2.8 on a number line, or the absolute value of 2.8. And so of negative 2.8. So that's how you would read it. Hey, the absolute value of negative 2.8, that's what we're looking for. And how you would think about that, we're simply wanting to know how far is negative 2.8 from 0 on a number line. So I'm plotting, you can see a number line, and I'm throwing 2.8 in. It's somewhere between negative 2 and negative 3, closer to negative 3. Just going to draw an arrow to it and label the distance as 2.8. I don't care that it's to the left of 0. Again, distance doesn't care about direction, and those negative and positive symbols are directional. Okay, if we were looking at a number line that's vertical, we would know to go below 0 to plot those. Negative 3 would be here, negative 2 would be here, and negative 2.8 would be closer to negative 3. So I'm just doing a quick sketch, drawing an arrow to get to it, and then the distance down below 0 is also 2.8. How this would look just in a full problem is we would say negative 2.8, the absolute value of negative 2.8 equals 2.8. Then we can ask, what's the absolute value of positive 2.8? And we run through the same thought process. Well, yeah, this reads the absolute value of 2.8. That's how you would translate those symbols into words. And then we would say, how far is 2.8 from 0? Well, it's between 1 and 3 again. Or sorry, 2 and 3. Can get closer than that. And I would just draw an arrow to say, hey, I'm going to this spot right here, and it's 2.8 units. Same as if it were below or above 0, same distance. 0 would be down here, 1, 2, 3 on a vertical number line. it would be just below the 3. And to sketch an arrow to that point, we could say that distance is also 2.8. This problem would look like this. It would just be positive 2.8, not negative. Positive 2.8 inside the absolute value brackets. The absolute value of 2.8 equals 2.8. Okay, we're going to use these 3 examples to try to come up with a single formula for finding the distance between 2 points on a number line. So the first thing we're going to do is we're going to graph each point on the number line. So I'm going to graph 3 here, and 8 I'm going to graph is up here. Okay, and now we're going to draw an arrow to show the distance each point is from 0 on the number line. So I'm just going to go above the 0 and just draw an arrow to get to 3. And then I'm going to go above that, and I'm going to draw an arrow to stretch to 8. And then I'm just going to label those with the number 3 and 8. So the distance here is 3, and the distance here is 8. I'm going to put that a little bit above because I want to break this up. Excuse me. So basically, we're just trying to see how much farther this number line, or this segment here, this piece for the 8, how much farther do we go? If we go from 0 to 3, how much farther is it to get to 8? Well, you can visually count that and see that it's 5 units. And from here to here is 3 units. So the total is 8. And the other way we want to think about it, which is the mode I want you to try to get into, is, hey, if we want to find this segment from here to here, we just subtract 8 minus, we take this piece off, 8 take away 3. So this is a subtraction situation, and that's the mode I want you in. You can count, there's other ways to do it, but I want you to think about the subtraction. We could do, I'm going to move that over, and you should too, over here. We could do 3 minus 8 to find that 5 value, right? And we get negative 5. Okay, well, that doesn't give us a distance because we get a negative value. So we could switch it and go 8 minus 3, and we'll get our positive distance. So the distance is 5, and to find this distance, we just take off and we subtract. Okay, the next one we're going to plot. We're just going to plot negative 7 and negative 2. And we're going to draw arrows to get from 0 to negative 7 and to get from 0 to 2. I'm going to draw that a little higher to negative 2. And again, we're not so much interested in the direction we went, just how far we went. So I'm going to label 7 above my 7 segment and 2 above my 2 segment. And I'm going to try to figure out what part I need. Well, I need from here to here. How much farther is this arrow compared to this one? Well, it's simply 5 units farther. We can count it out, or we can take that 2 off. I'm going to move my 7 up. I'm moving everything. That's all right. Here to here, we already did that 2. Okay, so I know this piece is 2, so this piece must be 7 minus 2, or 5. So we take that away from our 7 and we get the distance. So I'm going to write that subtraction problem down. We can do negative 7 minus, that's the numbers I was given, so I have to use what I'm given, negative 2, and I get negative 5. Okay, my distance came out negative again. It's not what we really want. We want it to come out positive. To get that to happen, I got to flip this around. Negative 2 minus 7. Whoops, minus negative 7. Which is negative 2 plus 7. Which is that positive distance we're looking for. Okay, one more to go. This one, I'm going to go to negative 3. I'm going to go to positive 9. Oh, there isn't one. We're just going to label it. It's just 1 past 8 there. And then we're going to draw our arrows. See how far these are from 0. Well, this one is 3 units and this is 9 units. So how far apart are they? They're 12 units apart. You can see that, but to find the distance between 2 points, or to how far, we got to do subtraction. So we're going to try subtracting these and see what happens. So -3 minus 9. When I do -3 minus 9, I get -3 plus -9. If you need to KAO to see that, do it, which is -12. Okay, that's 12 units, which we said this is 12 apart. We can see that, but we get our negative version. So to get it to be positive, I got to switch that subtraction around. And I get 9 plus 12. I'm sorry, 9 plus 3. Because subtracting a negative, add a positive, and you get 12. Okay, so it seems weird that we have to be careful on how we subtract because I could end up with a negative distance and that doesn't make sense. But really, we do not have to be careful. You have the ability, you know the skills for subtracting and adding integers and rational numbers. So how we're going to combat this situation where sometimes we'll get the negative version of it and sometimes we'll get the positive version of it is we're simply going to institute absolute value. We are going to say, hey, our formula needs absolute value bars on our numbers so that when we are done, we end up with the positive version of distance. So right here, we even put it on the numbers where we get the positive version. The formula is just one formula that we can use no matter what ordered pair, what numbers were given for the number line. We just stick them on there. And when we're done simplifying it, we get the positive version, which is the distance. And again, we can put it on both because it will come out positive either way. I'm just throwing those absolute value bars on both sides here to get this formula where we're finding the distance between 2 points. So going through those problems, we should have just remembered again the 2 key pieces for finding a distance is that distance is a difference, which means we're going to subtract every time when we're trying to find the distance between 2 numbers on a number line. And the distance should always be positive, so we're going to put those absolute value bars on to guarantee that no matter which way we choose to do our subtraction, which number goes first and which number goes second, we're guaranteed to come out with positive distance. Okay, so here's our example 1. So we're just going to follow the formula here. There's 2 of them available to us, and they're basically just saying switch the numbers. So here I'm saying, hey, put your second number first, and then put your first number second in the subtraction problem. And on the other one, I'm saying put your first number first and your second number second, just how you read it left to right. Just drop them in. It doesn't matter which way you do it because you put the absolute value bars on it. Even though we reverse the subtraction, one will come out negative, one will come out positive, and when we take the absolute value, they will both end up positive. So let's just do this one using the formula where we're going to put the -12 first. So we're going to apply this one. And I get -12 minus 8. When I do that, I'm going to funnel the steps all the way through. Some of you already know the answer without having to KAO, which is fine. You don't have to KAO. And we get -12 plus -8, which is the absolute value of -20. And we got the negative version, so we get +20. We're going to come over here and do it the other way to show it doesn't matter. 8 minus negative 12. We should get positive 20 inside these bars. We get 8 plus 12. 8 plus 12 is 20, and the absolute value of 20 is 20. So we get the same thing. It doesn't matter if you put this the first one in first or the first one in second. You get the same thing. All right, example 2. We're going to apply this using this formula first. Let's put negative 7 in first and negative 2 in second. We get the absolute value of negative 7 plus 2, the absolute value of negative 5, which is positive 5. So we got the negative version inside, but our absolute values took care of that for us. Let's switch it. Negative 2, take away negative 7. It's going to take care of it right here. Negative 2 plus 7. There we go. And we get 5, and the absolute value of 5 is 5. So it works out the same. Again, one version will give you the negative answer. The other version will give you the positive. In both cases, we put our absolute value bars on our work, so we know we are finding a positive distance. All right, so now I want you to practice finding the distance between 2 points on a number line. So it says here, here's a reminder of your formulas. It says show the computation for finding the distance between two given integers. Use the number line as needed to confirm your work and answers. Okay, so in the first piece, I want you to be using the numerical expression. So you should have the absolute value bars in your numerical expression and the subtraction problem. Then you're going to funnel it like we did in the example 1 and 2 above. You're just going to work your way down to get to the answer. And your answer should always come out positive because distance is always positive. So you're going to do these 3. You're going to pause the video and then turn it back on when you're done to see how you did. Okay, so I showed both ways you could have done this problem, depending on which formula you chose to work with. And so just look at for the one that you did you have negative 8 first? We'll look at these steps. Did you have negative 2 first? Look at these steps. And just see if you got these correct. The first version here, if you put negative 8 first, you should have had the negative 6 answer, which came out 6. Positive 6 answer if you reverse it. And then this one, negative 7, I had first, which drove me to my negative 10 answer. And if I put the 3 first, I ended up with a positive 10 in the absolute value brackets. So both of them ended up 10. And then this one, I put my first number 5 in. And when I did the math there, it gave me my negative version for the distance. And then I took the absolute value to get the distance, which is positive 5. And then if you reverse it, you end up with just positive 5. And so the formula you'll see most of the time in textbooks and when you Google is this one right here. This is the preferred way. They, for some reason, want you to use whatever the second number is into your formula first. But again, it's totally up to you which way you do it. You just, if you work it out correctly, the signs will take care of themselves in the problem, and then the absolute value will make sure you get the right positive answer when you're done. And a number line is always another good way to confirm whether or not your answers are right. So you can always sketch a number line and see if your answers are making sense based on the pictures you draw. Okay, so I'm going to have you try these 3 problems. So I'm going to have you pause the video and try them out. But I want you to use, I'm going to have you use this formula right here so that I don't have to do both ways. And your work should match mine because we're both using the exact same formula. Remember, x2 is going to be this value first in your absolute value bars for your subtraction. So use that formula, write the expressions with the absolute value bars, and then simplify them. And then, again, use your number line if you need to confirm that your answers are making sense, if you need a visual. And then turn the video back on to see how you did. Okay, so you should have set up your expressions. Check to see if we have them set up the same way. We're subtracting 13 from negative 35, in the first one. And when you do that, you get negative 35 plus 13, which is negative 22. And the distance, the absolute value of negative 22 is positive 22. Second one, negative 20 plus negative 32 is negative 52. Absolute value of negative 52 is 52. And finally, if we're doing 29 minus 45, we're going to subtract 45 minus 29, which gives us negative 16 because there's more negatives than positives. And the absolute value of negative 16 is 16. So that should hopefully have helped you find the distance between 2 points on a number line using that formula. So now we're going to take a look at some real-world problems that involve thinking about this concept of how far apart 2 points are. And in this case, it all involves elevation. So Fort Wayne sits at an elevation, that means, above or below sea level, right? An elevation of 810 feet above sea level. Denver, Colorado sits at an elevation of 5,280 feet above sea level. So both of these places are above sea level. What is the difference between their elevations? So the first thing I'm going to do is I'm just going to come over and mark where Fort Wayne is. We're about right here. I'm going to put an FW there. And then I'm going to mark where Denver, Colorado sits. It's between 5,000 and 5,500. It's it's a little above halfway, so it's about right there. So I'm going to just put Colorado, Denver. Okay. So I have my 2 cities marked, and I can see that they're going to be less than 5,280 feet apart because I'm already at 810 here. So the expression is going to be the distance between those 2 points will give us the difference between their elevations. So I'm going to start with Denver, 5,280. It is the bigger number. It is positive, though, because it's above 0. And I'm going to subtract 810. And when you do that subtraction, you get a positive 4,470. And the absolute value of positive 4,470 is 4,470. So the distance between these 2 elevations is 4,470 feet. So we can use elevation as a way to show and illustrate distance between points on a number line, technically. The number line is a really good tool or strategy to just visualize what's happening in your problem so that when you're done, you can see that your answer makes sense. From here to here is 4,470, which makes sense because it should be less than 5,280. Again, because we're already above 0. All right, here's another one. I want you to read this one on your own and try it out. And I want you to just kind of plot some numbers on the number line to get a sense of what's happening in the problem. And then write your expression and simplify it to see a difference between these 2 record temperatures. So read the problem carefully, set up your expression and plot your graph, and then compute and then figure out the record temp between these 2 hottest and coldest temps. Okay, so the numerical expression I used, I put the 134 first and the negative 128 after the subtraction. And I ended up getting, adding them together for 262. Again, if you reversed it and you did your subtraction, you would have ended up with a negative 262 here, but it comes out positive. And the graph itself, you can see that just to get from here to here is 128 degrees. And if we keep going to try to reach the other point, we have to go another 134. So you can see it pans out that this ends up adding the 2 values together and then making sure your answer comes out positive. So the difference between the hottest temperature on record and the lowest temperature on record is 262 degrees Fahrenheit. That does conclude the lesson, so make sure you understand the formula for finding the distance between 2 points on a number line involving absolute value and subtraction.